Algebra 2, this is test review for Wednesday's test. As you can see from the top, I am starting on page 69, and I'm going to go through page 72, and I'm going to do one or more of each type of problem you could possibly see on Wednesday's test. So, the instructions for problem 1A say solve each quadratic equation below, show how you determined your answer, and luckily above they are giving you the quadratic formula to use. So keep in mind that your quadratic must be in standard form before you set up this equation. And as I always tell you, when you put it in your calculator, always put parentheses around the b before squaring it. And the a, I'm doing a very bad job here, let me try my finger. And the A and C, so that when you use negative numbers, it multiplies correctly. So we can put it around the 4, we can put it around the A, we can put it around the C. All right, so the first problem, I see 3x squared minus 9x, and if I think about what my order is for solving or factoring, it always starts with GCF, greatest common factor. The reason I know to use greatest common factor is because this is a binomial, 1, 2 terms. And also, I notice that I can divide both 3x squared and negative 9x by the same number. That same number is 3x. So remember, 3x doesn't go away. It goes over to the side, and then I do separate divisions of 3x squared divided by 3x and negative 9x divided by 3x. And this is what it looks like in factored form. Once our quadratic is in factored form, we can set each factor, both 3x and x minus 3, equal to 0, and then solve each equation separately. To get x by itself on the left, I'm going to divide both sides by 3, and then I'm going to simplify saying x equals 0. On the right, x minus 3 equals 0. That means I have to add 3 to both sides. So my two solutions are 0 and x minus 3. Keep in mind that for this one, because there is no radical, there is no reason to check for extraneous. Letter B, they tell you already that it is factorable. And I taught you that you're looking for two of the same numbers that multiply to negative 15, the last number, and the same numbers add to the middle term. Well, if it's negative 15 but positive 2, those numbers are going to be positive 3 and negative 3, positive 5 and negative 3, in which case you're going to write these in factored form. Always an x in front of each parentheses, x minus 3 times x plus 5 equals 0. That doesn't go away. And then just like A, you're going to set each factor equal to 0 and solve. Again, no radical, so no need to check for extraneous. C tells us to use the quadratic formula, which is on top of your page. So the first thing I'm going to do is I'm going to label my A, B, and C. Make sure that the sign goes with the number. For example, this negative 6, don't forget the negative. Also notice, I never include the x's. Your answer should not have an x in it. It should just be a number with a radical sign, no x's inside. So only pull the numbers from the equation in standard form. Put it into your quadratic formula. Notice I used all of my parentheses, and as I've told you before, to simplify this part, use your calculator, but do not include the radical. For example, I'll call up the calculator now, and I'll make sure that I'm not in y equals because I'm not putting in an equation. I'm going to do just like it says. I'm going to do negative, let's see if I can get a negative here. Hold on, move this out of the way. Negative 6 parentheses squared minus 4. That doesn't need to be in parentheses. The 1 needs to be in parentheses in case it's negative, and the 4, which is your C term. Now, That means the number under the radical is 20. That is what goes in your radical sign. So simplified, it should be 6. Oh, I forgot plus or minus. There's always two solutions to every quadratic. 6 plus or minus square root of 20, and the whole thing over 2 times a, and a was 1. To solve something that's in vertex form, if you recognize this, this is in vertex form. A times x minus h squared plus k. So we're going to use the square root method, but in order to undo, you're going to have to use the opposite of PEMDAS. You're going to have to use what I call SADMEP. You're going to have to subtract and add first, then divide, then multiply, and then use the rules for your exponents and your parentheses. So since I have to subtract or add first, I'm going to subtract 20 from both sides. Then I'm going to divide or multiply. 5 is multiplied by x minus 4 squared, so I'm going to divide both sides by 5. Negative 20 divided by 5 is negative 4, and now I can get rid of my exponent according to SADMEP. Getting rid of a square uses a square root, and I notice that I'm square rooting a negative. If I'm square rooting a negative number, then I have to employ my I. Remember, I is the square root of negative 1. So I'm going to change my radical, first of all, to say plus minus, because there are two solutions. And then second of all, I want to change negative 4 to negative 1 times 4, then change it to two radicals, which you're allowed to do, because the square root of negative 1 is I, and the square root of 4 is 2. Final answer, well, I'm sorry, not final answer, because you still have the 4, x minus 4. So x minus 4 equals plus minus, square root of 4 is 2, square root of negative 1 is I, and then the last step is to add 4 to both sides. Notice how I branch off into two different solutions. One is going to have a positive 2i, and the other one's going to have a negative 2i. So when I'm adding 4 to both sides, again, because it's a quadratic, I make sure I have two solutions. There they are. Next page, please. Page 70. Okay, page 70 requires you to find the zeros of the function. So I'm going to remind you words that mean the same thing as zeros, so it's easy to find on your graph. Zeros are the same as solutions, are the same as roots, and most importantly for a graph, the same as x-intercepts. X-intercepts hit the x-axis, and if you look at this graph, it hits the x-axis at 2 and at 5, and so when it asks what's the zeros of the function, meaning the functions that make the y value 0, or the x-intercepts, the answers are going to be 2 and 5. Page 71. Okay, now this one you must check for extraneous because you are squaring to get rid of a square root. So you need to make sure that both solutions work. So in order to get rid of a square root, you're going to square both sides. Oh, sorry about that. I didn't mean to draw this line here. So squaring both sides, the squaring gets rid of the square root. Because you're going to get two solutions and it's a quadratic, you're going to put it in quadratic form. Quadratic form means I want all the terms on one side of the equal sign and the equation set equal to 0. So I'm going to subtract 2 from both sides. I'm going to add x to both sides. And now if you look at the right side of my equation, it's x squared plus x minus 2. This is factorable. Two numbers that multiply to negative 2 that add to negative 1 are positive 2 and negative 1. And if you remember from putting things in factored form, it's x plus 2, x minus 1. Both of those sets of parentheses set equal to 0 and solved. Subtract 2 from both sides, so one solution is x minus 2. Add 1 to both sides of the other factor, x equals 1. Now notice I crossed out x equals -2 and wrote extraneous and left x equals 1 circled with the word real around it. The reason I did that is because, as I said before, when you have a radical, you must check for extraneous. So here I am checking for extraneous. I'm taking the original equation, and everywhere I have an x, I'm plugging in -2. So here is my equation, -2 on the left, and then 2 minus -2, making it 2 plus 2. So now you want to ask yourself, is -2 the same as the square root of 4? It is not. So you're going to go back to this solution over here, and you're going to go back to your solution over here, and you're going to cross it out. You're now going to do the same thing with x equals 1. You're going to plug it into everywhere you had an x in that original equation. So now rather than x equals 2 minus x, it's 1 equals 2 minus 1. Simplify your inside the radical so that 2 minus 1 is 1. The square root of 1 is 1. 1 equals 1. So x equals 1 is real. Page 72, our last page. Now, I'm going to show you how to do this in your calculator, but notice how it says you must show your work. So you're only going to use the calculator to check your answer. So first, let's do the math. The instructions I wrote said take out the parentheses, because if you have a plus sign between the parentheses, then the plus sign doesn't matter and the parentheses don't matter. So then you're going to rearrange all the real numbers together and all of the imaginary numbers together. Parentheses gone, and then 5 plus 7, and then the plus 3i minus 3i. 3i minus 3i is 0, so your answer is real, and it's 12. Let me show you now how to check in your calculator. So I am going to clear this, and I'm going to make sure my mode is on imaginary. Go down to where it's, oops, nope, back to here. Mode, oops, sorry. Mode, go down to where it says real, and because you're doing complex solutions, one more down. I can't do it. Make sure it's on A plus BI. For some reason, it's too small. It's not. Yeah, I can't do it. So let's put the function in our calculator. It's going to be, oh boy. It's going to be 5 plus 3. Here's I. Second period gets you I. Plus 7 minus 3. That's supposed to be a 3. 3. Second period gets you an I. And then when you hit enter, you can see that your answer is 12. So I'm now going to do the next problem. When I look at it, I believe that it is multiplication, and it is. How do I know? Because there's no plus sign between the parentheses. It's parentheses times parentheses. When you have that, that's going to be FOIL. You're going to multiply the firsts, 3 times 5, that's the F. You're going to multiply 3 times -6i, those are the outside terms. You're going to multiply 4i times 5, those are the inside terms. And lastly, 4i times -6i, those are the last terms. So start doing all of your multiplications. 3 times 5, 15. 3 times -6i, -18i. 4i times 5 is positive 20i. And 4i times -6i is -24i squared. Remember, I taught you that I squared equals -1. So get rid of the I squared and put a -1 there. Now notice, -24 times 1, -1 is positive 24. That's a real number. So now you have to combine this number and this number. And because everything has to be in A plus BI form, it's going to be 15 plus 24 plus 2i, and 15 plus 24 is 39. I'm now going to show you how to do this again in the calculator. Pray for me. So it's going to be 3 plus, whoop, already wrong, too small, 4 plus, nope, 3 plus 4i times, remember, you must show your work. You're allowed to do this after you do the algebra, meaning all the work I just showed you how I got. Okay, you prayed for me, but it didn't work because my fingers are too fat. All right. Hit enter, hit enter, hit enter, 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 enter. There we go. 39 plus 2i, which was the same answer we had before. Last problem has a negative, and so you're going to distribute the negative before removing the parentheses. So that means everything that's positive becomes negative, everything that's negative becomes positive. 3 becomes negative 3, and negative 5i becomes positive 5i. Then you want to put the two real numbers together, 5 minus 3, and then you want to put the two imaginary numbers together, 2i plus 5i. Final answer, 5 minus 3 is 2, and 2i plus 5i is 7i. Remember, you only want to substitute -1 when it's I squared. I hope this helps. You're to finish the packet as test review for Wednesday's test. Bye now.